So in this video, we are going to talk about duration. So the main topic is measuring price volatility of a bond. There are several approaches for that. So the three measurements commonly used to measure price volatility is DV01, price value of basis point, which is not covered in exam FM, and the duration, which is going to be two types, Macaulay and modified. Actually, they are connected, and then the convexity. So in this video, we are going to talk about duration and the both type, Macaulay and modified duration. So first, how we are going to define price volatility. So the price volatility of bond can be defined as percentage bond price change divided by change in interest rate. So that's how you define the price volatility. So basically, it's in real sense, it's the instantaneous change. So you have to take the derivatives. But if you approximate it, it's going to be delta P over P. So that's the percentage bond price change divided by the change in interest rate. So this quantity you can calculate using this formula. And then you divide by the change in interest rate. So this quantity is going to be negative for bonds without option, such as callable bonds. The negative for bonds without option. The callable bonds are bonds with option. Okay, so let's go to the first topic. So this is basically the definition of price volatility, but then we are going to convert it to a unit, like the measurement unit. So first thing we are going to discuss here is duration. So the duration of a set of cash flow is a measure of how sensitive the price of portfolio is to shift in the interest rate. If the portfolio has duration 5, then for small h, it will lose about fraction 5h of its value if the annual rate goes up from I0 to I0 plus h. And go up in value by approximately factor 5h if it's decreased. Okay, so just remember the curve we draw for the bonds. So here you have the price. Here you have the yield rate. And then here is the I0. And so this one is I0 plus H. And then this one is basically I0 minus H. So you can see that if the rate goes from I0 to I0 H, I0 plus H, if the duration is 5, the price is going to be decreased by a fraction, okay, 5h of its value in the annual effective rate. So fraction 5h of its value. Okay. So this is the basic idea. We will see more concrete example than this. This is just a definition. So the concept of duration gives an investment manager a way of calculating what is interest rate risk, so as to control that risk and match asset and liability for his entire portfolio. So this is called immunization. We are going to discuss this later. So as of now, just to know that fund manager need to match these things. So there are two types of duration, modified and Macaulay duration. Macaulay duration is simply called as duration. Actually, these are connected. Okay, so connected concept. So here is the first one, modified duration. So modified duration is defined using this formula. So basically, it's derivative of price evaluated I divided by price I. So remember the formula here, the price volatility. Okay. So so if I write it down, it's basically so this is basically a derivative of price respect to I. So P prime I divided by PI. Okay. So that's the price volatility. Now the problem with that, this one becomes usually negative. So you will see this negative sign in front of that, make it to positive. Okay. So price volatility. So this one is called the duration. Duration, modified duration. Okay, so you can use the modified duration, this notation. And if I write the price PI, how you calculate the price? So let me draw the timeline. So here you have this cash flow C1, C2, Cn. The idea is price would be what? C1 times V plus C2 times V square, and so forth. If I expand this, V is actually 1 plus I to the power negative 1, 1 plus I to the negative 2, so forth. So if I take the derivative P prime I, that's going to be what? That's going to be negative 1 time C1, 1 plus I to the negative 2. And then negative 2 times C2, 1 plus I to the negative 3. So that's why you see here this T time CT 1 plus I to the power negative D plus 1. So this is basically derivative. Okay, then you have the PI. So since you can see every, when you, I mean, this is a negative derivative. Okay, so you can see derivative contain negative sign. So if I take negative sign as common factor, I would get something like this. So then that since the definition is negative time P prime I over Pi, this negative sign cancel out, negative time negative, that's become positive. So that's why here no negative sign. But here you will see the negative sign. Okay, there's a negative sign. Okay, so that's how you calculate the modified duration. So here you can see more clear explanation why someone want to define modified duration that way. The first thing we can do using Taylor series, we can expand price Pi about any rate, given rate I know. Okay, so this is Taylor series. And then you can see you can bring this to other side and then divide by Pi naught, then I minus I naught, and then you will get this nice expression. Okay, so of course you can see from here Pi minus Pi naught is going to be this P prime I naught, I minus I naught, 1 factorial, so forth. I minus I naught is common factor, so you can take it and you can divide by that. So that's why, so then you will have this nice expression. So that would be P prime I naught over 1 factorial plus P double prime I naught time I minus I naught, not square, but just 1 now, because you take 1 I minus I naught as common factor, 2 factorial. So then you divide both sides by the price. Okay, so here you add the Pi naught, and then so here you add the Pi naught, then here you add the Pi naught. So you get expression. So we have approximation of price volatility. Okay, so we have price volatility. So this is basically what we mentioned. This is approximation of this quantity. Divide by. So then this part, you can see it's very close. It's basically you can replace by modified duration. Okay. So you can say, so basically now, so that's going to be equal to, so this one is basically modified duration, then the plus some other term, okay, this the rest. So when you remove this, the rest, you get a approximation. Okay. So basically modified duration is approximation of price volatility. Okay, so and then if you cross multiply, you can see that pi is going to be equal to pi naught plus pi naught. I mean, if you cross multiply, let me cross multiply here. So this one you can actually write as delta I. So let me erase that and write delta I. And then here is approximately equal to negative value of modified duration. So now you can multiply. So this is going to be then pi minus pi naught is basically negative pi naught delta I, because basically this is going to be the same denominator, and then time d mod, and then now you can bring it to the side, so you get this nice expression. Or you can write like this. Okay. So so basically now you can see price volatility is approximated using the modified duration. So that's the key insight why we calculate that. But also you can observe that we are really forgetting about these second derivative, third derivative terms. So when you add the second derivative term, you get, that's basically convexity. That's why you saw that in earlier another slide called the convexity. Because we need to think about, can we make it more accurate by adding the second derivative or third derivative? Because this is actually approximation, not the exact value, because you are forgetting about the other terms. But it's a good approximation, so so we can use it in our calculations. So let's try to understand modified duration. So here we can find two links, and here is the meaning. Suppose that modified duration of cash flow is 4.22. This means if rate increased by 100 basis point, then price would decrease by approximately 4.22. Okay. So how we explain that? So let's go back to here. Okay. So this is pi minus pi approximately equal to pi naught minus pi naught d mod delta I. So if the modified duration is 4.22, so let's substitute that. And the rate increased by 100 basis, so 1%. Delta is 1%. So 0.01. Then the price would decrease by 4.22. So you can see how much price decrease. This is new price minus old price over old price. That is approximately 4.22 times 0.01. So if I convert it to 100%, it's exactly equal to 4.22%. Okay, so the price decrease because you have this negative sign in front of you. Okay. Yeah. So that's how you understand the modified duration. So basically, it give you a sense what happened if rate increase or decrease. What's going to happen to the price? Okay. So the Macaulay duration will be different from modified duration. Macaulay duration is defined using this formula. So basically, this is not a derivative. Okay, so right away you need to observe that this is not the derivative. So it's defined like this: T Ct 1 plus I to the negative t divided by price. So that's called the Macaulay duration. So then you will see that, of course, if you divide this by 1 plus I, if I divide d by 1 plus I, what do I get? I get sigma t Ct 1 plus I to the negative t plus 1 over pi. So this is basically modified duration. So Macaulay duration divided by 1 plus I equal to modified duration. Okay, so you can get that relationship right away. So how do you understand macro duration? Macro duration is the weighted average of the time to receive the cash flow from a bond. Okay, so it's really different from the modified duration. So it's a weighted sum, time weighted. Okay, so average of a time to receive the cash flow from the bond, because you can see that. So basically, you have this time 0, 1, 2, all the way up to, let's say, n. Here you get C1, C2, Cn. Then when you discount it, it's going to be what? So I'm going to C1 time 1 plus r is negative 1. When I discount this, it's going to be C2 time 1 plus r is negative 2. Now I'm multiplying, I'm waiting according to the time. So I'm multiplying by 1, and this one by 2. Then if I have this one, this would be n time Cn 1 plus r is negative n. So this is the discounted values, but these are weights. Okay. So that's why the weighted average of the time to receive the cash flow from a bond. Okay. So then you divide by the price. It is measured in units of years. Macro duration tells the weighted average time that bond need to be held so that the total present value of the cash flow received is equal to the current market price paid for the bond. Okay. If you have time, please read this article. It gives you more explanation about macro duration. So you can see that macro duration interpretation is a little bit different from modified duration. Modified duration is defined as price change or price volatility of a bond. But macro duration is defined as the weighted average of the time to receive the cash flow from a bond. Okay, so two different interpretation. So here are some properties of macro duration. Duration of a coupon paying bond is always less than its maturity. For non-coupon paying bond, the duration is same as its maturity. Of course, you can prove this part very easily. For if I have only one cash flow, like time n only Cn, then what's the macro duration? So it's going to be, if I use the formula from here, this formula, macro duration. So the price would be Cn time 1 plus I to the negative n. Then the macro duration is basically n time Cn time 1 plus I to the negative n, because you are weighting each cash flow by time, they divide by the price. And these two cancel out and you get n. Okay, so that's why for non-coupon, the zero coupon, okay, basically this is zero coupon bond, the duration is same as the maturity. For anything else, it's less than maturity. Bond with longer maturities have longer duration. This is because the coupon payments will be spread over longer periods and will be more affected by inflation. And the bond with higher coupon rates have lower duration and vice versa. So coupon rate and percentage change are inversely related. So when you have higher coupon, then the lower duration. When you have longer maturity, longer duration. So just remember these things. The units of duration are time units, period or years. Okay, so for example, if this is like 6 months, then the duration would be in 6 months. And so like how you measure the time. When you draw the timeline, how you measure the time. Is it 6 months, or is it 1 year, or is it quarter? Based on that, your duration unit based on the periods of years. So again, more explanation. The macro duration calculate the weighted average time before bondholder would receive the bond cash flow. Conversely, the modified duration measures the price sensitivity of bond when there is a change in the yield to maturity. So it's a two different concepts, even though they are related. So otherwise, you may wonder why, if the modified duration is macro duration divided by 1 plus I, why we are defining two different quantities? Because these, even though these are related, they measure two different things. Okay? So one for the price sensitive, one for the weighted average time to receive the cash flow, invested cash flow. So here's one more Macro duration is a weighted average of the times until the cash flows of fixed income instruments are received. The concept was introduced by Canadian economist Frederick McCoy. It is a measure of the time required for an investor to be repaid the bond price by the bond's total cash flow. The Macro duration is measured in units of time. Relative to the Macro duration, the modified duration metric is more precise measure of price sensitivity. It is primarily applied to bonds, but it can also be used with other types of securities. The modified duration figure indicate the percentage change in the model value given X% of rate change. Unlike Macro duration, modified duration measured in percentage. Okay. So again, two different concepts. So here you can see few formulas. Of course, this one we already derived. So if you have duration of level payment investment, then this is the approach. That can basically, so let's say you have a payment like this, $1. This I start for $1. So this is 1, 1, 1. Then what's the duration? Duration is you take that one time. This is for time, okay? Just remember the formula, let me write the formula. T time, CT time, 1 plus I to the negative T divided by price. Okay. Anyway, what's the price here? The price would be, this is annuity, no? So basically it's annuity immediate with N payments. So the price is AN. But then then when I try to do the numerator part, it's going to be what? It's going to be one time, $1 time, 1 plus I to the negative 1, then 2 time, the payment is $1, 1 plus I to the negative 2, so forth. So basically it's an increase in one. If you look at this, this is look like what? This look like I'm taking the present value of arithmetically increasing annuity. Okay, I mean the numerator. Okay, so it's 1 to n because you have 1, 2, and so forth. So the present value is usually in this notation. Okay? Increase in annuity, 1 unit. So this stands for increase in annuity, present value of increase in annuity. So you can do the same thing with the bond with face value F and coupon F per periods and redemption value C, and you get this one. And duration of zero coupon bond is N. So these are the things you need to learn. Okay, so let's try to do a few examples and see how to use it. So this one is saying, suppose payments of 2,000, 4,000, and 10,000 are to be made at time 1, 2, and 4. Assume an annual yield of 25%. Find the duration and modify duration of the investment. So let's do the timeline. At time 1, time 1 is 2,000. Time 2, 4,000. Time 4, 10,000. Okay. So you need to discount to get the price. So the price would be under the rate 25%. So it's 2,000 time 1.25 because rate is 25%, which is really high actually. Negative 1, then 4,000 divided by 1.25 to negative 2, then 10,000 divided by 1.25 to negative 4. That could be the price. Then for the duration, you need to calculate this quantity. Remember sigma t ct 1 plus I to the negative t. Okay, so that would be 1 time, 2,000 time, 1.25 to negative 1 plus 2 time, 4,000 time, 1.25 to negative 2 plus 4 time, 10,000 time, 1.25 to negative 4. So let's use our calculator and see what would be the answer. So 2,000 divided by 1.25. Then 4,000 divided by 1. I mean the 1.25 to 1, okay, not negative 1 here. If you bring it to numerator, it's going to be there. It's 4,000 divided by 1.25 square plus 10,000. So this would give you the price as 8,256. Then the other one, so one time, you can see calculation become a little bit tedious. Um, 2 times 4,000 times 1.40. 4 times 10,000 times 1.25. So I get this one as 23,104. So I can calculate the duration. Basically, that value. So that would give me 2.798. So there's no unit, so it's just a time unit. Because it doesn't make, it's not specifically mentioned whether it's a year or what the measurement unit you use to measure this 1, 2, 3, 4, the time unit. Then the modified duration is going to be d divided by 1 plus I. So we divide 2.798 by 1.25. So which is basically 2.23. Yes, okay. Okay, so here's another question. Consider 2 bonds purchased at the redemption value of 1,000 and due in 5 years. One bond has 5% annual coupon rate payable semi-annually, and the other has 10% annual coupon rate payable semi-annually. Find the duration and modified duration of each bond if both bonds were purchased to yield 7% compound semi-annually. So one bond has 5% annual coupon. Basically, we have to think the redemption value is 1,000 and the same as the face value, because we need to calculate the coupon. So, and then the 5% annual coupon rate payable semi-annually, and the other has 10% annual coupon payable semi-annually. Find the duration and modified duration. So the bonds due in 5 years. Okay. So I have 0, 1, 2, 3. So you can see that we have 10 coupons. Okay, because every 6 months you're going to get a coupon. The coupon amount is one has 5%. So 1,000 times 5%, which is 50. 5%, but payable semi-annual, so it's 25. Because the rate is given as nominal rate. So it's 25. And then 1,000. Then the other bond is same, but you have different coupon rates. Redemption value is 1,000, but the coupon is 10%. So for this one is 1,000 times 10%. Again, that's nominal rate, so it's 50. Okay. Find the duration and modify duration of each bond if both bonds were purchased. So the rate is 7%. compounds the manner. So if I divide for this one, it's going to be 3.5. For 6 months, the effective rate is 3.5. Okay, so let's calculate the duration. So how you calculate the duration? Let me do this one, and then you can do the other ones. Okay, so the duration wise, this would be what? This would be sigma Ct 1 plus I to the t time Ct 1 plus I to the negative t divided by price. So what's the price? Let's calculate that. We can use our calculator. For this bond is payment. Let me piece it. The payments are 25, and the redemption amount is 1,000, and then there are 10 payment, and the rate is 3.5, and we need to complete the percent value. So it's 916 and $83. So the price is 916 and $83. Now this one we have to write it and calculate. Okay, so let's see how to do that. So this one would be what? So this one would be first one is time is 1, t is 1, but the cash flow is 25, and then 1.035 because the rate is 3.5 to the power negative 1. The second one 2 times, then again the cash flow is 25, 1.035 to the negative 2, so forth. The last one would be you have two components. Let me expand this. So the last one you have this 25 and also 1,000. Okay, so you have time is 10, and then you have 25 and 1.035 to negative 10, plus then you have 10 times because you have redemption value 1,000 and 1.035 to negative 10. So we can calculate the price there. Okay, so so you can see right away 25 is common factor. So if I take 25 out, I mean the post sum, okay, except that $1,000 one. So here then I have like 1 time 1.035 to negative 1, 2 time 1.035 to negative 2, so forth, plus 10 time 1.035 to negative 10, and divide by this price. Right away, you can see that this is going to be really time-consuming calculation. So we need some kind of Excel sheets or something. So in exam, it would be more like simpler question for the exam FM because they can ask something simpler in this case. So 1.035. So let's do this calculation and see what we are going to get. So let me do the calculation using my calculator. So doing this using calculator is really hard. Um, but I want to show you how to do this. So then the next, maybe we can skip some of these other calculation. This is not from a SOA problem. So um, basically you won't see this kind of problem in the exam. So I'm doing the 8 time. 1.035 to -8. Then 9 time. Then 10 time. Okay, so I got so the top one, for here I get 1084.641641694. Plus I still have to do that this one. So let me do that one. And divide by 60. So let me add these two and divide by 16.83. So I get 8.953. The unit, this is duration, and we use a 6 month, no? So 6 month period. So basically what it's saying, it to take approximately 4 years. So if you, these are 6 month periods. So if I take the year wise, if you, that mean what? 4.45. So you take 8.91 units to is required for an investor to be repaid the bonds price by the bonds total cash flow. You remember the macro duration definition. Now from there you can get the duration, which is d divided by 1 plus I. Okay, so now you can divide this one by 1.035. Which is 8.6138. That's the modified duration. That's the how much price would change for 1 basis point change in the bond price. So this one is a little bit harder because without Excel function, it's hard to calculate. But let's try to do this problem and see how to get the answer. Find the duration and modified duration of 10-year zero coupon bond, assuming yield 8% effective. So right away, you know the duration is, because it's zero coupon, it's just the maturity. D is 10. So then the modified D is basically D divided by 1 plus I. So it's 10 divided by 1.08. That one is easy. But this kind of problem is not that easy, especially using calculator. So what happens if you have more than one bond in your portfolio or more than one asset? So here you can see how to calculate modified duration of a portfolio. So basically you take the weight for each component and then you multiply by its modified duration. The same for the macro duration. So weighted average. For example, if we invest $500 here in the portfolio 1, The other one is 1500. Then you divide this one by total, which is 2000. This one by 2000. Okay, so let's say you have only two components. So you take the weighted average. So here's example. Portfolio is 10,000 worth of 2-year bond with modified duration of 1.95. 40,000 worth of 4-year bond with modified duration of 3.71. So basically you add the total worth. So it's 10,000 plus 40,000 plus 50,000, which is 100,000. So then you can take the weight, 10,000 divided by 100,000, which is 0.1. Then the other one weight is 0.4. Other one is 0.5. So now you multiply the 0.1 time modified duration, which is 1.95. Okay, for the other one, 0.4 time also modified duration, 3.71. Then the other one, 0.5 time also modified duration, which is 5.5. So this is the portfolio, but for the portfolio. So here is to have another similar type problem. So now let's see what kind of problems you will see in the exam. So in the exam, you're not going to, they can give, but usually it should be something a little bit easier. The current price of annual coupon bond is 100. So you don't have to calculate the price. Okay, so it's given. So you can see how they make it easier. The derivative of the price of the bond with respect to yield maturity is -7. So basically you are given the derivative too. The yield to maturity is an annual effective rate is 8%. So I is given. Calculate the duration of the bond. So from here you can see you can easily calculate the modified duration, which is defined as negative P prime I over Pi. So basically negative 700 over 100, which is 7. Now you can use this relationship, d divided by 1 plus I is modified duration. So d is going to be modified duration multiplied by 1 plus I. So basically 7 times 1.08. So it's not like this problem where you have to write long expression and do all the calculations. So they have given some of these quantities. So here is another question. John purchased 3 bond from portfolio as follows. Bond A has semi-annual coupon at 4%, duration of 21.46 year, and was purchased for 980. So you are given the duration, which is 21.46, and the price is 180. Bond B is 15-year bond. Duration is, so let's say this bond A. Then the bond B duration is 12.35 years, the unit, you can see the unit. And the price is 1050. Then the bond C, duration is 16.67 years, and the price is 1000. Calculate the duration of the portfolio at the time of purchase. So we want to calculate the duration of the portfolio. So you can see that you can easily calculate the total value of the portfolio. Okay, so what's the total value of portfolio? So 980 plus 1015 plus 1000. So this one give you what? Let's use our calculator. So this one is 2095. Okay, so now we can divide 980 by that total value. And because now we are taking the weighted average, 21.46 plus 1000 divided by 6. So that would be the duration of portfolio. So these kind of problems are simpler than what we try to do. So here's another exam problem. So this one says common stock pays dividend at the end of each year to perpetuity. Assume that the dividend increased by 2% each year. Using an annual effective rate of 5%, calculate the macro duration of the stock in years. Okay, so here is 0, 1, 2. Pay dividend. So let's assume the dividend amount is D, then the next year is going to be increased by 2%. Using annual effective rate of 5%, calculate the macro duration of the stock. So plus what's the price? So you can see that you can discount this, so it's going to be one. This is like geometric series. So we are discounting by rate 5%. So this would be D time V. So what is V? V is 1 over 1.05. So you can see dV is common factor. So if I take that, I will get 1 plus 1.02 times V, 1.02 V whole square, so forth. This would be dV. Remember geometry series, this look like X, this look like X square. This goes to infinity, so then the sum is going to be 1 over 1 minus X. And given that absolute value of X is less than 1. So now I can substitute the price, the V is there. 1 over 1 minus X is going to be actually 1.02 times V, which is 1 over 1.05. So, okay, so remember X is 1.02 times V, which is 1.02 times 1 over 1.05. So when you do this, you can easily see this is going to be 1 over 1.05 because V time 1.05 is going to cancel out. So you will end up with D time 1 over 0.03. Okay, so basically D divided by 0.03 or 100D divided by 3. Okay. So now so that's the price. Then we want to get the when you're calculating macro duration, you have to calculate this quantity. So this is basically sigma CT T CT 1 plus negative T over price. So let's calculate this quantity. That's going to be what? That's going to be 1 time D. This is basically V, no? So let's write that way, 1 time dV. Then the next one is 2 time dV square, so forth. So it goes to infinity on the price. So, so if you take dV as common factor, you can say it's 1 plus 2 by the way, this is increasing, so let me give this 2 times d time 1.02, then e square, so forth. So if you take dv as common factor, this one will be 2 times 1.02 times v, then 3 times 1.02 times v square, so forth. So you may have to find a formula to get this one. how to get the sum of that. So I will leave it that to you. Right now, I don't get idea for that, but you can find a, formula and then try to solve that part. So then once you get that, this quantity, then you can divide it by the price to get the modified macro duration. So let me stop here, and then we will meet again to discuss the rest.